Welcome students. My name is Dr. Pranith, and today we will see about the part 5 of this very interesting topic about amines. So in the last class we have seen the what are amines, how to prepare the amines and their reaction, and today we will see the important properties of amine, that is basic nature of amines. So now let's move on to the topic now. So basicity of amines. So what is meant by base actually? See, the base is the basic nature is of any amines, for example, is due to the presence of the lone pair of electrons on the nitrogen, right? You can see here this is a primary amine, that is the, we have also seen the classification, right? Primary, secondary and tertiary amine. This is a primary amine, CH3NH2. So the nitrogen contains two lone pair of electrons here. Contain two electrons that is present on the nitrogen atom. This is the methylamine. So the basic nature, so amines are basic in nature. Base means can be able to donate the electrons, or it can be able to release the OH minus ion, right, hydroxide ion. So the basic nature is due to the presence of lone pair of electron to this one. So the amines are basic in nature. So amines are also Lewis base, right? Lewis base. What is Lewis base? Lewis base are electron pair donor. It can give the electron pair. So the amines are Lewis base because it contains two lone pair and it can donate easily. So it is a Lewis base also. It is basic in nature because of the presence of lone pair of electron. This is an important concept you have to remember. Now let's move on to look carefully the basicity. So here there are two compounds given. One is the ammonia NH3 and the next one is the methylamine CH3NH2. Okay, both contain two this lone pair of electron here in ammonia also and also in trimethylamine. So which one is more basic? So this question we can ask, no, which one is more basic, whether it is ammonia or the methylamine. So here the main difference is difference between ammonia and this primary amine is, this methylamine is, one of the hydrogen atom is replaced by a CH3 group. You see, ammonia contains 3 hydrogens and the amine contain only 2 hydrogen atom, and rest is the CH3, one CH3 group. So one hydrogen is replaced by CH3 group. So the important point to remember in this one is CH3 group is an electron donating group. It's an electron releasing group. We all know this, right? CH3 is an electron releasing group. So CH3 group increases the electron density because it is an electron releasing group. It can increase the electron density because there is a push. The electron push from the carbon, the CH3 group, towards the nitrogen. So the electron will be pushed here. So the electron density will be here, will be increased on the nitrogen, right? So what happens if you have this electron push, electron density increases, this amine can easily donate this proton, this lone pair of electrons, right? After all, Lewis base is electron pair donor. So if you can easily donate the electron pair, it will be more basic, right? This concept can come because this methyl group is an electron releasing group. That's why it's written that therefore the electron pair can be easily available for protonation. Protonation meaning is H plus attachment, right? Proton attached. This is protonation reaction. Due to this reason, this methylamine is more basic than ammonia. So this is the reason the methylamine is more basic, not the ammonia, because having a CH3 group, it's an extra power. It gives an extra power, extra push of electrons from the CH3 to the nitrogen atom. So the basicity will increase because the electron pair can be easily donated in the case of methylamine and compared to ammonia. So now let's move on to see these three basic amines I have shown here, right? Methylamine, that is a primary amine because it is having an NH2 group, and the secondary amine, that is dimethylamine, secondary because it is having only one hydrogen and 2 hydrogens are substituted by the, for example here it is 2 CH3 group. And finally tertiary amine because there is no hydrogen in this. So which amine will be more basic? This question we can raise. We have seen that compared to ammonia, primary amine is more basic. CH3 NH2 is more basic because compared to ammonia, there is one CH3 group is there. CH3 group is an electron donating group. So electron donating group, what it will do? It will push electron density, making the electron pair to be donated easily. So it is more basic. Now here you can see, compared to the methylamine, there are two CH3 group in the dimethylamine. There are two CH3 group. So more powerful, more electron push happening. So it can easily donate this electron pair. So this will be more basic than methylamine, right? This is the, we can assume like this is more basic than the, and this is a valid assumption because if you have only one CH3 group, you have two CH3 groups, this should be more basic because two CH3 group can push the electrons because it's an electron releasing group. So this ammonia can, this NH2, NH can release the electron pair. If we compare to the tertiary amine, what we can assume is there are three CH3 groups, so it will be more powerful than the dimethylamine because it containing 3 CH3, so more electron push, so this electron donation will be very easy, right? So according to this assumption, we can say the tertiary amine will be more basic than secondary amine, that is this one, and this is more basic than the primary amine, and primary amine is more basic than ammonia. However, there is a huge difference. When you compare, in reality, the secondary amine is more basic, this is secondary amine, is more basic than the tertiary and primary amine, okay. So, you forget about this letters, this whatever written, only check the structure. So, this is in reality the secondary amine that is having two CH3 group is more basic than the primary amine and than the tertiary amine. The tertiary amine basicity is almost equal to the primary amine. So, why this in reality, why this is happening? This is supposed to be the more basic, right, according to the, because it is having 3 CH3 group, and according to the assumption that this 3 CH3 group is providing electrons, so this lone pair of electron can be donated easily. However, that is not the real case. In the real case is the tertiary, secondary amine is more basic than the tertiary, and the basicity of tertiary and the primary is almost same. That's why the simple is written. So why the primary amine is secondary amine is more basic, and why not? Why the tertiary amine is less basic? Okay, so this here you can see the reason for the less basic nature of tertiary amine. Right, this is the actual scenario. Actual scenario is primary amine is more basic. That's why this greater than sign is written here than the tertiary, and tertiary is equivalent to primary. The tertiary amine is not so basic because, of course, it's contained 3 CH3 group, but it can create crowdness. Okay, it can create crowd because this electron pair is located on the nitrogen, but this 3 CH3 group also is present on the nitrogen. That makes it crowded. Okay, this is present in the orbital. These two electrons are present in the orbital, right? And because of this crowdness, this electron pair is not easily available. That's why the tertiary amine is supposed to be more basic. That is true. However, due to the 3 substitution CH3 groups on the nitrogen atom, steric hindrance happens. The crowd. Steric hindrance meaning is crowdness. And due to this steric hindrance, the lone pair of electrons are not accessible easily. So this is important point you have to remember. This 2 pair is not cannot be donate easily because of this 3 CH3 group. Therefore, the basicity of amine is decreased. Okay, the decrease compared to the secondary amine. This is the important point. However, in the case of dimethylamine, you still have not so crowded because you see there is one NH group here and only one CH3. Here is having one CH3 and 2 NH group. So primary and secondary, this crowdness is not so affecting compared to the tertiary. And even you can imagine if you have more bigger groups like ethyl group or propyl group, right? CH3, CH2, CH2, CH3, CH2, CH3, CH2, CH3 here, it will be more crowded, so it will be less basic even compared to the primary amine. Okay, so this is the, if you get crowdness, if you get more bulky groups on the nitrogen, the basicity will be decreased. So this is important. Um, the property of the amine, the basis property of amine, we have to follow this criteria. Why basicity decreases or increases based on the substitution group. So with this, let's move on to check the test for amines. So there is important a test to be conducted to check the presence or absence of amine is Innsberg test. So Innsberg is a scientist name, and this test is used to detect primary amine, okay, to find out the presence of or absence of primary, secondary or tertiary amines. So in the case of primary amine, this test give water soluble product in the test. So if you take any sample, unknown sample which is having primary or secondary or tertiary amine, if you add this Innsberg reagent, I will tell you soon what is this Innsberg reagent. So if you add this Innsberg reagent, what will happen? Primary, if it is a primary amine, it will give a water soluble product. Okay. Interestingly, if you have this secondary amine, it will give water insoluble product. So primary amine will give water soluble product, secondary amine will give water insoluble product in the test. So this way you can say that this is present. Okay. Of course, we can isolate and we can check what is the product. This product is important because if there is no product, no reaction. This is what it is happening in the tertiary amine. Tertiary amine does not react, does not undergo any reaction in the test. So using this simple test, Innsberg test, we can detect whether it is a primary amine, secondary amine or tertiary amine. So now let's check more insight on this reaction. So this is the Innsberg test for primary amine. What actually it is happening, what is the actual reaction is going on. So this is the primary amine structure. For this example, I have given here methylamine. Okay, this is a primary amine. Methylamine is a primary amine. And this is the Innsberg reagent. This is the reagent used for testing this reaction. This is the benzene sulfonyl chloride. Okay, this is the benzene sulfonyl SO2 chloride. So benzene sulfonyl chloride is the Innsberg reagent. So you have to remember the name and the structure of this reagent. This is very important. So when these two will react, I told primary amine will give water soluble product. What is the product? This is one. Sulfonamide, SONHCH3. This sulfonamide is the, so sulfonyl chloride is SO2Cl. Amide group is CONH2. This amide group. Sulfonamide is SO2NH2. This is sulfonamide. But you have substitution here, so it is still called as sulfonamide group because SO2NH. This group is still present, so it is sulfonamide group. The product is water soluble product. This product is water soluble because it is having a NH group, NH group, right? This NH can hydrogen bond with water, make it soluble. Okay, that is because of the hydrogen bonding. Plus HCl, because one hydrogen, one chloride and one nitrogen is gone. This will attach here and this product is formed. Okay, so one hydrogen coming from here, one chloride coming from here, so we get HCl as a byproduct. Remaining two things will attach. Okay, so CH3NH will attach in the place of chlorine. So you can see here benzene SO2 NH, one hydrogen is gone and CH3. So conclusion is primary amine give water soluble product in the test, and this is the product sulfonamide. So now let's move on to check the test for secondary amine. So if a sample containing secondary amine, if an unknown sample, what will happen? You can add, out to test, you can add this Innsberg reagent, which is this benzene sulfonyl chloride, right? And this is a secondary amine. This is the example I took. This is a secondary amine, CH3, NHCH3. What you will get is again water sulfonamide, SO2 and double CH3 because CH3 is CH3, and this H hydrogen, this H and chloride is gone as HCl. So secondary amine will give water insoluble product. We have seen in the introduction of the test. So this is the product, and this is the sulfonamide. Again, it is a sulfonamide because SO2N, N is there, right? SO2N group is sulfonamide. So why this is insoluble? Because there is no hydrogen. There is no hydrogen on the nitrogen atom. So there is no possibility of water hydrogen bonding with water, right? So it makes it insoluble product. So conclusion is secondary amine gives water insoluble product in the test. Now finally check what is the test for tertiary amine, how the tertiary amine will react. Interestingly, tertiary amine will not produce any reaction, will give no reaction, no product. If you have sample containing tertiary amine and if you add this thionyl chloride, the benzene sulfonate chloride, no reaction, no color change will be there, nothing will be there. The reaction will be quiet because see that hydrogen is not there. How to remove the HCl? There is no hydrogen here. HCl cannot go. If HCl cannot go, this cannot attach here, right? So we see compared to this secondary amine picture, you can see there is a NH group here. This hydrogen and chloride will go away and this will attach here. But in the case of the tertiary amine reaction, there is no such possibility of attaching this group to the benzene sulfonate chloride. So no sulfonamide formation because there is no hydrogen in the tertiary amine. Right? So this is a reason for no reaction. So if there is a reaction and if the reaction produces a water soluble product, right, you can do some spectroscopic studies to find what is the product, right. This is beyond this topic, so I'm just telling we can find the product easily. What is the product? We can find out by many techniques. So if it's a product and if the product is water soluble, then it is primary amine. If it is a product formed and if it is water insoluble, then it is secondary amine. And if there is no reaction, so it means no product, then we can conclude that this amine is a tertiary amine. So like this, we can, using the simple test, this reagent, this is available in all the labs and very cheap, we can easily find out which amines are present, right. So far we have seen the properties of amine, the important property, that is the basic property, nature of amines, why the primary amine is more stable than ammonia and why the secondary amine is more stable than the primary amine, right, why the tertiary amine is less basic because of the crowdness, and then we have also seen the test for amines. So this inspect test can be carried out to find out different amines. So far this is all for this today's class, and for the next class we will see about some uses of amine, and we will also move on to see that regarding the acids, carboxylic acid, the reaction, the interesting properties and all. So see you in the next class. Thank you.